students, enthusiasts. Welcome back to my channel. So as you know, that we mostly discuss about electronics topic related to project, related to subject. So they have come up with a new project idea, that is rain detection and rain intensity control, car wipers speed control using ESP8266. So as we know, it is a low cost automotive automation project. Low cost automotive automation project. So let's go and see what is there. That is first the abstract part. Rain detection and rain intensity control are hyper speed control using ESP8266 is an intelligent automotive safety project that automatically adjusts the speed of windshield wipers based on detected rainfall. It means the speed, how much speed the rainfall is coming, automatically detect, and accordingly, a rain sensor measures the intensity of rain and sends data to the ESP8266. Because we are using the microcontroller, that is ESP8266. Now, why we have used ESP8266? We could have used a smaller Arduino or Nano board here. Why we have used ESP system? Because we can do advanced project, that is the same project. We can take it to the cloud and other things. So that is the reason I have come up with this idea, that is ESP8266. Depending upon the rain level, the system controls a servo motor acting as a wiper. Okay, I'll show you how the servo motor works over here when we go to the lab, and different speed while displaying real-time rain information on OLED display. So, like you have latest cars or EVs where you have a display. So display will be shown what is the intensity of rain so that you can control or you get alert or the wipers, that is the windshield wipers are controlled automatically. The project improves driving safety, that is the reason, by reducing driver distraction and demonstrates practical application of embedded system, sensors, automation, and modern vehicles. So it is an embedded system and automation based project. Okay, right. So components used very simple, as we have already discussed. Node MCU, that is ESP8266. This board we have used it. We have used simple rain sensor, that is the number FC37 or YM83. You can use that as sensor. Servo motor SG90 or MG995. This is the number, but you can get it from the market. That is 5-volt motor. Then you have an OLED display SSD1306, which you can see it here. That here your breadboard, jumper wires, and power supply. So power supply, either you can give it to this power, that is your battery. Why? Because please remember, don't connect the servo motor directly to this. Why? Because it will take a lot of time. So here you have to use a battery to run the servo motor. Okay, over there. So before going into this thing, we should know the working principle first. So how does it work when there will be no rain? The sensor value is high. These are not high. The numbers will go across the near about thousands, right? 1,000. Servo remains off. That means the servo is off, and there is the OLED display will say no rain. Light rain, that is when the light water falls on the rain sensor, then you will have a slow servo sweeps slowly. It will move slowly because the rains are light. So OLED display light rain, it will show. Medium rain, it will show medium range, and the servo will go for a medium range. That is a little faster than the light rain. Heavy rain, servo sweep rapidly, and LED will be written very. Now, this future enhancement part, you can add Blink IoT monitoring to this. That is the reason why we have used 8266. Display rain percentage on the big dashboard can be seen, or we can add additional headlight control. That means when the rain goes medium or high, you want that automatically your headlight should get on. The vehicle headlight should get on. So that also we can add it in our codes. Speed, that is vehicle speed control according to rain intensity, that also we can do. Automatically, it will control the acceleration. When it is an EV, it will control the acceleration and the speed will automatically come down. Long rainfall data to cloud storage. We can send rainfall data to storage also. Why? Because we give you that whether this particular area, how the rainfall is happening. GPS-based weather warning system also we can develop. So these are the few of the ideas what we have discussed. Okay, the circuit connection finally. So rain sensor is connected to A0, that is analog 0. we have to give 3.3 volt supply, which we have given for ESP32 itself. And servo motor, please remember, which is connected to D5, that is GPIO 14. Here you have to be very careful that the supply is to be given from external supply, that battery or adapter. Okay. So 5 volt is to be separately given and the ground should be common. OLED screen, simple, low current consumption. So 3.3 volts ground to ground. SDA is connected to D2, that is GPIO 4, and SCL is connected to D1, that is GPIO. So here in the bottom side, you can see I have drawn a small block diagram. That is a rain sensor. Rain sensor is connected to ESP8266. Power supply, separate power supply to servo, and ESP will control servo as well as the display. So this is a simple connection. Let's go to our lab. All right, friends. So we have come to our labs. So I will just give you the example. First, I will tell you what are the parts we have used. So first of all, this is my servo motor, which works like a car bypass. This is my microcontroller, that is ESP8266, or we call it as a node MCU. This is my rain sensor, the light where it is coming, and here the rain will fall. This is SSD1306 OLED display, which is showing rain value, that is 10. When the rain value is high, please remember it is no rain or wipers are off. Okay, that means the motor is off. Okay, and this is the battery from where we have given supply for this motor. Okay, so this you have to, these are the parts. The connection I've already told you that everything that is the SSD, and this is working on 3.3 volt, which I've taken it from the node MCU itself, and the 5 volts I've given it from here. The connections in D3, D4, D5 is given to the sensor, and D1 and D2 are going to the OSD display. Okay, and this is out, and okay, A0 is here. So we have given connection from this side, this corner, you can see. Okay, that is the rain sensor connection. The sensor connection is there. So D5 is output for the circuit. I hope you understood this part. So as you can see now, the rain, it is showing no rain and wiper is off. So what I will do is I will just pour little water on this sensor, showing that it is raining. Okay. So let's see, I have put one drop. It is showing the value has come down to approximately this thing, and the wiper is in medium position. You can see the wiper is moving. You can set the angle and it will be moving. So when it goes very below, that is, if it is going, see, you can see now it has come to high. So the speed will increase automatically, and the wiper, this thing will be there, and as well as it, you can see the things are working here. So as we have already discussed, that you can add so many things, that is, you can go for the IoT project. This is non-IoT, please remember. This is right now, it is non-IoT project, but we have used ESP8266 so that we can connect it to the cloud. As we have already discussed, Blink Cloud or any other cloud we can connect, and we can do the things. Okay, we can do our project based on IoT. So I'm rubbing it. You can see I'm just removing the light. Slowly it will be moving around, and it will be coming to the normal position. Okay, at that time, now it has come to medium position, as you can see, and automatically when it comes to very high value, like you can see the number of movements are there. When it reaches the high value, at that time it will be stopping up. So this is very simple project, but you can add accordingly your other things. You can add to it, and you will get the result out. Very simple. You can use it in your car. This is good for the cars which have a manual system. Like you have to put a button and you have to use it. Now it has stopped. The wiper has stopped. You can see because I have removed the water on the sensor. Okay. So this is a very simple project. I hope you like it. I will definitely share the codes with you. This is our rain intensity micro. You can see it's working. On the others, you can picture. So we'll discuss about the code parts here. So 4 libraries, you can see. The 2 libraries are for display, and one is for servo, and one is for connection, that is via .h. Then screen width, what we have taken for the display, and this is the connection, the A0 and D5. D5 is for motor and A0 is for this thing. So position, it starts from 30, direction 1. So there are 2 directions. I've given the code up to OLED display is D1 and D2. I've given the code up to 90 degrees. That is right. The servo will go up to what distance. This is important. Please remember the rain value. Okay. So this initially we have to give light rain, that is it will display what will be the value, and if it is more than that, it will show like that. If it is more than 400, then it will be showing medium, and heavy rain, it will be showing above that, it will be showing below that, sorry, it will be showing heavy rains. So these are the value status which will be given, which are there. And the speed of the motor we have given here, 0, 25, 12 and all. That is the PWM pulse motor. And delay will be 100 milliseconds. And these are the position. Okay. So I've kept press has to go on one side and has to come back again to 30 to 150. So likewise, I've given the simple code, non-IoT. Please remember, we can do it IoT, and we can add the headlight as well as the engine speed also. So this is our code, and I will be sharing this code. So if you like it, or if you have any questions, please do write me. If you like it, please subscribe and share it with your friends. Thanks for watching. See you next time.